I'm Faria Choudhury, student at Queensborough Community College, majoring at Computer Science and Information Security. I'm doing research on extending the identities for the Fibonacci and the Lucas sequence of the solution of a generalized from the Pell equation. My mentor name is Professor Dr. Andrew Bulawa. I'm gonna talk about in details today about my project. My project is about the Fibonacci sequence, and this Fibonacci sequence is the sequence of a number that begins with 0 and 1 and follow a recursion relationship, which is f of n equal to f of n minus 1 plus f of n minus 2. If we put any value for n, we can compute any values for the Fibonacci sequence. And the corresponding sequence of this Fibonacci sequence is the Lucas sequence. And the Lucas sequence starts from 0 to 3, 4, 7, 11, 18, 29, 47, 76. And the key idea of my project is realize that the Fibonacci sequence arises as an integer solution of the equation. The equation is that x squared minus 5y squared equal to plus minus 4. So if we solve this solution for some x value and y value, we'll get for x value we'll get the Lucas sequence, and for the y value we'll get the all Fibonacci sequence, which I already listed in the table here. The goal of my project is to consider the sequence y of n and the x of n that arises as the solution of the equation of the form that is x squared minus my squared equal to plus minus this square. This is the most general equation for my project, and the origin of every equation comes from this equation. For this equation, for m and d, we can use any arbitrary integers value for m and d. And for this one, I found in my research project that the minimal solution is gonna be a and b for any equation. This is comes from x squared minus my squared equal to plus minus this square. When we got any equation, we can plug in the minimal solution a and b, and we can compute the recursion relationship for x squared minus my squared equal to plus minus this square. And the recursion relationship for more general case is p of n, which is p of n equal to 2a over d p n minus 1 minus plus p of n minus 2. Let's give an example for a more clear idea. Let's m equal to 2 and d equal to 1. Then the more general equation here is m equal x squared minus 2y squared equal to plus minus 1. And I already mentioned about the minimal solution. For this equation, x squared minus 2y squared equal to plus minus 1, the minimal solution gonna be 1 and 1. And for find out this minimal solution, I took help of the Maple software. This is the most popular mathematical software, and I did some code by which I can easily find out for any equation. I find out the minimal solution. So for this equation, I get minimal solution 1 and 1. So when I plugged in all the values, we got the recursion relationship for this equation. This is p of n equal to 2 p of n minus 1 plus p of n minus 2. So right now, if we solve for x value and y value, this equation, for the y value, we got the Pell sequence, and for the x value, we got the Pell-Lucas sequence, which I already mentioned here. The Fibonacci sequence f of n satisfied the Cassini's identity. This is the main point of my project. The Cassini's identity for the Fibonacci sequence is f of n minus 1 times f of n plus 1 minus f of n whole square equal to negative 1 to the power n. For my general equation, the analogous identity for yn is y of n minus 1 times y of n plus 1 minus yn square equal to negative eta to the power n plus 1 times b square, where the eta related with m, b, d, a, and b. So eta equal to a square minus mb square over d square. And I was able to prove this using the method of induction. Right now, I am working to extend the following identities. I already put all the list here, and this is all of these identities related with the Fibonacci sequence and the Lucas sequence. I'm trying to extend all of these identities for my general case. This is x square minus x square minus my square equal to plus minus d square, and hopefully I will able to extend all of this identity for my more general case. Thank you everyone for watching my video.